You can go to literally any electronics store right now and buy a 43-inch 1080p monitor for maybe $200.
Oh, easily.
Mm.
Maybe even less if it's on sale.
Right, exactly. So why on earth is a hospital paying nearly $1,500 for a Hall Technologies screen with, like, the exact same basic specs? Okay, let's unpack this.
It is a really great question.
Welcome to today's deep dive, where we are exploring the invisible, highly regulated infrastructure of healthcare. We're looking at the HT-HVM43 medical HD monitor, which is sold through HDTVSupply.
Yeah, and on paper, I mean, the technical specifications are incredibly pedestrian.
They really are.
It runs at a standard 60 Hz 16:9 aspect ratio, basic HDMI and DVI video inputs. Plus, it just has standard built-in speakers.
So literally a cheap entry-level TV.
Exactly. If you put it right next to a budget consumer television, you wouldn't even notice a difference in the picture quality.
Which makes that almost $1,500 price tag look, well, kind of absurd at first glance. If the resolution is standard 1080p, what exactly is the premium for here?
Right, so you have to consider the environment. This isn't for watching movies in a living room.
Right, it's for a clinical workstation.
Yeah, running 24/7. And sure, it boasts a 50,000-hour lifespan, which is great, but standard commercial displays have decent longevity too. You're really paying for the absolute elimination of risk.
Well, even the advertised feature that the on-screen display menu buttons can be locked down. Wait, locking the brightness buttons? Is someone really trying to sneak in and mess with the contrast during a diagnosis?
What's fascinating here is that the real danger in these zero margin for error environments isn't malicious tampering.
It's not.
No, it's just accidental human error. In a busy emergency room, staff are constantly moving around, brushing past equipment.
Oh, I see. Like nurses and doctors just bumping into things during a shift.
Exactly. If someone bumps the contrast button on a consumer TV, your movie looks a little washed out.
Right. Annoying, but not a big deal.
But if someone bumps the contrast on a medical monitor, a subtle shadow on a radiological scan might just suddenly disappear.
Oh, wow. That physically alters a diagnosis. So a doctor looking at a compressed dynamic range might miss an anomaly entirely just because, a nurse's elbow grazed the bezel.
That is the human risk factor, right? But the real engineering cost goes into mitigating machine risk. This monitor holds strict IEC and EN 6060111 and 6060112 medical certifications.
Okay, those standard numbers usually deal with electromagnetic compatibility, right? Like EMC.
Yeah, you get it.
So is this basically preventing the monitor from acting like a localized radio frequency jammer in an intensive care unit?
That is a great way to put it. Standard consumer electronics use cheap, unshielded power supplies.
Right?
And they constantly spew these noisy electromagnetic frequencies. In your living room, that doesn't matter at all.
But in an ICU, I imagine that's a completely different story.
Oh, absolutely.
Yeah.
If you put that unshielded power supply next to a highly sensitive EKG machine or a ventilator, that electromagnetic leakage can actually scramble the patient's heart rate readings.
Wait, really? It can mess with life support?
It can disrupt life support pacing, yeah.
That is terrifying. So a standard TV is practically radiating invisible electrical pollution?
Pretty much, yeah. To fix that, the Hall Technologies monitor has to use heavily shielded, isolated circuitry to trap that noise internally.
Okay, so it contains the noise.
It does, and it isolates the electrical current itself. Those certifications guarantee that even if the internal components fail or short out, it won't leak dangerous currents to the chassis.
Because that could shock a vulnerable patient, or short out an adjacent machine.
Exactly. It is engineered to be a complete electrical fortress.
So what does this all mean? For you listening, I think it gives a newfound appreciation for the hyper-reliable, hidden engineering that quietly keeps us safe.
When we are at our most vulnerable, yeah.
Right. We tend to focus on the million-dollar MRI machines, but even the humble wall monitor is this carefully controlled instrument.
If we connect this to the bigger picture, the actual value in healthcare technology isn't flashiness or bleeding-edge resolution.
It's not about 4K or 8K specs.
No, it's uncompromising stability. You are paying for the guarantee that a device will do its exact job without introducing any new variables into a high-stakes environment.
Which completely reframes how you look at the infrastructure next time you're in a clinic. And that leaves you with a final thought to mull over.
Oh, definitely.
If wired, stationary hospital screens require such rigorous physical lockdowns, shielded circuitry, and strict anti-interference certifications just to sit quietly on a wall... Wait, let me emphasize that.
Go ahead.
Just to sit quietly on a wall, How vulnerable is the booming market of wireless wearable personal health tech to the invisible chaos of our everyday environments?